Hi viewers, Easy Physics. Video number 6. In the earlier classes, I have explained you different parts of the physics. In the different parts, I have mentioned the first part is motion. That is the state of motion. In the state of motion, I told you that sometimes we will speak the object if it is rest or in the what I we call that equilibrium state. It means that the net force will become zero. And the second one is when it is under the motion. So we can say that the state of motion which speaks about that is called as mechanics. In the mechanics, we have dynamics and kinematics. So dynamics and kinematics, whatever it may be the branch. Now I would like to explain you about, first of all, there is very important concept in these things is FBD. FBD is nothing but free body diagram. F stands for free, B stands for body, D stands for diagram. So what is FBD? FBD is nothing but the easy way representation of an object and the forces which are acting on it, whether it is under the motion or at the rest. So some steps we have to follow for the FBD. The first step is you can represent any object in the universe either by the block or by the dot. And there are the several different forces. Suppose normal force, usually upward. Gravitational force. Sometimes white is also downward. Force applied. And some other forces also I can mention that friction. And tension. We can represent all these with different arrow marks in the direction of they are working, and we have to remember that the magnitude of the arrow mark is also very important. If the arrow mark is larger, it means higher force is applied. If the arrow mark is smaller, it is low force is applied. I will explain again all these things in a different examples. I can give you different examples. For example, a book on a table. First example, I can say that a book on a table means you are not supposed to draw any a table or a book or something like that. Simply you can draw it as a arrow box. So what are the forces works on the book on a table? First of all, book is having a weight, so it wants to go down because of the gravitational force or because of the weight. So we have to represent this one. But the table will not allow the book to fall down. It means that it is applying the normal force against of the gravitational force on upward direction. So this is the representation FBD of a book on a table. Whatever it may be, it is a book on a table or a something is on a table. Whatever the material it is, we have to represent with the box. And as these two are equal and as the book is at rest, the magnitude of the arrows must be also equal. Now, a leaf falling from a tree. Now, we need not suppose to draw a tree and a leaf. Simply we have to draw a box which represents the leaf. Now, what are the forces acting on it? Of course, we have to sometimes ignore some forces, or we can consider the forces. If suppose any buoyancy forces which works over the leaf, it may be negligible and the leaf will fall down as it is attracted by the gravitational force. Hence, we can represent with this arrow mark. If there is any force of air works against the leaf, and if the leaf is floating in the air, then you can represent with normal force against of it. But normally the gravitational force is more larger than that of these forces, hence the leaf will fall down. So that is the reason we have to represent like this. Suppose another example, I can say that a man is hanging by capturing two different hangers. Let us suppose I would like to make the free fall FBD diagram. This is the man and two different forces are acting on him to hang himself, but still gravitational force works on it. So this is the tension, this is the tension, and of course this is the G, or rather we can say that W. So the free body diagram is a representation that can enable us to understand what are the forces acting on it and what are the exact position of the object when these forces are acting on it. It may be at rest, or it may be at motion in uniform or non-uniform. I will give one more example. A block is drawn towards the left side. A block, this is the block. Let us suppose it was drawn towards the left side. So you can put it like this. When it is drawing towards the left side, automatically there will be a frictional force works over it. Then we can put it as small arrow. The capital F represents the force applied, external force applied on the block, which is representing on the left side because it is traveling on the left side, and the frictional force is there, but it is negligible. So the force is overcome the frictional force and it is taking away from the to the left side. Hence we can say that the diagram is like this. Suppose the same object moving towards the right side. It doesn't require, if it is no frictional force, simply you can put it like this. Even if it itself also having any frictional force, they are always in the opposite direction. Suppose if you take an aeroplane is moving from right to left. Then let us suppose this is the aeroplane. It moving from right to left. Still It is having weight on the gravitational force, and there is an a upward force is also there, but it must be larger than the that of the weight of the object. So if you observe these diagrams, we can understand the different forces which are acting on object, and